In this video, we'll learn how to build an app based on a standard marketplace template. This app will use the MetaMask crypto wallet to log in and the Polygon blockchain Matic coin as payment. The first step is to create a new app. Select the marketplace template and choose the right billing plan. In this case, the startup billing plan will work well. Now, let's take a closer look at the app. Go to the Web Pages section where you'll find a link to the marketplace. We see that so far there are no goods in the marketplace. To address this, go to Databases, click the Other Actions button, and then the Refresh Search Indices option. Let's go back to the marketplace, where we now have goods, along with images and descriptions. We can also add goods to the cart, but look, at the moment, only authorized users can add items to the cart. So, we add user authorization through the MetaMask crypto wallet. To do that, go to Plugins and select MetaMask. Keep permission to register new users. Add the appropriate name, in this case, Polygon, to the network name field, and copy the address of the wallet that's going to receive cryptocurrency transfers to the owner address field. Let's check that logging in through MetaMask works. You should be able to log into the marketplace through the MetaMask cryptocurrency wallet. Next, we confirm the login with the plugin for Chrome or other browsers such as Yandex. And now we can see that a new user has been registered and authorized. Now we can add items to the cart. Let's try and add one item to start with, and then another. We confirm that there are 2 items in the cart. The cart itself is a specific object within the database. Have a look at a standard database structure from the marketplace template. The goods structure contains goods with descriptions, images, and of course prices, along with a link to a merchant. In other words, a brand. The carts structure contains users' carts. Here in the object we see 2 links to the 2 items we just added to the cart. These are links to objects from the Item in Order data structure. The Orders structure is still empty. The Merchant structure is our sellers. There are different car brands, and they're displayed in the catalog. Let's go back to the Goods structure. If necessary, we can change each item manually. For example, we can change the price and other parameters. Let's try to change the displayed price, which we want to be seen in Matics instead of US dollars. Go to the Configure Fields button in the Goods structure, then change the name in the Price field, and add Matic instead of dollars. In our example, the cost is generated as a string, and the string is generated in the scenario called Update Displayed Price. This scenario runs for every new and modified object and generates a string with the price each time. To process all objects through the modified scenario, we need to add another start condition. Run manually for all objects. Save the changes and run the scenario for all objects in the structure. We see in the logs that the scenario works as we intended. Now we check how the price appears in the marketplace, and we see that the price is now displayed in the Matic cryptocurrency. Now, let's carry out the same operation for the cart object. We'll replace dollars with Matic. To do so, we have to go back to Scenarios and select the Calculate Cart Price scenario, where we replace dollars with Matics. let's change the content of the cart to see if it's worked. We remove an item. There. Now we see that the cost is displayed in the Matic cryptocurrency everywhere except for the table. To fix that, we go to the Web Pages section, then the Cart page, and select the Cards View settings. Then go to the Objects subscription and change dollars to Matic. Save the changes and update the page. Great! Now we see that everything looks just as it should. Now we have to figure out how the Checkout button works. We go back to the Web Pages section, then the Cart page. Select the Form Settings menu. There's only one button, which generates an object from the user action structure through the endpoint, which in synchronous mode calls on a scenario to generate a new object. It finds the cart and checks that it's not empty. Creates an order by copying the fields from the cart object to the order object and removes all items from the cart. Then the result from the synchronous scenario goes back to the user. We should check that it works. We check out with our items. Success! A new unpaid order has been created. Now we look at the data structure inside the platform. Go to the Database section, then the Store folder, and then the Orders structure. Let's delete this order for now, because we'll be changing the order creation process. We go back to the Web Pages section, then the Cart page. Remove the form, which we don't need anymore. Now we implement payment with the button on the card through what are called action buttons. Similar to the way we added items to the cart from the catalog. We've now added one item to the cart. Go to the Card View Settings menu, then the Actions subsection. Add a new action. Let's call it Buy. Just a button. Select an icon and color. In this case, the action shouldn't create or change any object, but call the Web3 API, which means it should call our MetaMask Wallet API. The amount is an obligatory parameter to be transferred. That means the amount of cryptocurrency to be written off. In our case, to transfer the amount, or more precisely, the item price, we must add that price to the endpoint of the cart and allow it to be read. In this case, it's the Sum field. We go back to the Cards View Settings menu, then the Actions subsection. The amount parameter is filled in from the object card with a numeric value from the field containing the cart cost. Let's try to click the button. We can see that MetaMask is running, which offers the option to write off the amount from the wallet, which is specified for all items in the cart. We won't do that yet. Let's experiment with the button settings. First, it can be displayed on the card itself. Click the Show button on the card checkbox. Now, let's add a message that users will see after success. We can temporarily change the amount to a random constant, such as 1 Matic coin. Save the card and see what happens. Now we see a button right on the cart. We can write off 1 Matic coin, and let's confirm the operation to see the success status message. The shopping cart hasn't been emptied yet. This means that we have not yet created an order. We see that the transaction was successful, and 1 Matic coin was transferred to the wallet that we specified while installing the MetaMask plugin. Now, let's figure out how to get transactions from the wallet. To do that, we need to install the Polygon plugin. Next, we need a scenario that will retrieve transactions from the wallet regularly. Because the scenario always works with an object, we need some kind of trigger object, which can be empty. Let's call it the fetch trigger structure. Now create one object with a random ID. Here we'll call it 1. Now create a scenario. For convenience, we can create a group of scenarios. It's a scenario to fetch transactions from the Polygon blockchain. This scenario will run on a schedule. We'll make it run every hour. This means that every hour, the scenario will fetch all objects from the specified structure. Because we only have one object in this structure, it means that once an hour, this scenario will process our empty object. Add the Fetch Transactions step from the plugin. It's essential to specify the wallet from which we fetch transactions as the address. The provider is polygonscan.com, the main net. We can register and get an API key at polygonscan.com. All the transactions we get will be saved in the crypto transactions data structure. This step has a link to this structure, but let's see how to find it from the structure tree. Publish and run the scenario. It will run regularly, but you can test it now by making it process an object by using the debugging section. We see that the scenario worked as intended in the logs. Now we go to the database section, then the integrations folder, then the crypto folder, and then to the crypto transactions structure. This structure has all the transactions that the blockchain stores for this wallet. For convenience, we can move this structure to the Web3 folder. Now let's check the whole process. To do this, let's change the cost of one item to one Matic coin. Theoretically, we can do this through the database, but the template also provides administration tools. We can see the merchant and user who owns the Mercedes-Benz goods. We can see that this user's name is David. We copy the login and set a password. Then copy the ID, which is also a login. Then we need to log out of our marketplace account. Log in again with the copied email and password. Now we see new tabs, My Merchant and My Goods. Here, because we own the goods, we can change the price. But that's still displayed in dollars. Why is that? To find out, we need to go to the database section, then the goods structure. Click on the Configure Fields button. The price field already includes Matic, but you need to resave the table to display it properly in the interface. Go to the Web Pages section, then the Goods card, then to the Table View Settings menu. Now everything is correct. Here in the catalog, the item's price is one Matic coin, and we can afford it. Log into the marketplace through MetaMask and add the item to your cart. Now we go back to the payment button settings in the cart. Go to the Card View Settings menu, then the Actions subsection. Put the actual amount back. That's the real price for the cart. and we can add two more parameters: the cart and user IDs. Actually, we don't really need the user's ID. It's already in the cart, but we can add it anyway, just to see how it works. Let's check the cart contents. Everything looks good. Click Buy. Confirm the transaction, and wait for it to be confirmed in the blockchain. Done. Let's manually run the Fetch Transactions scenario. This can be done by processing all objects in the scenario. Great! The scenario worked. Go back to the crypto transaction structure and look at the last object. Here's what we see. From whom, value, and the input field, where we have all the encrypted parameters that we configured for the button. Now let's create a scenario that will process this transaction. The scenario will work with the crypto transaction structure in real time on all new objects. For convenience, you can open an object, that's Crypto Transactions, in the next tab. First, let's deal with the transaction amount value. To make it look normal, add a context variable. Amount, and its type, decimal. You can also immediately add a cart ID context variable. It will be a link to an object from the cart's data structure. First, we add a value conversion step to a readable form. In the object, it's stored in Way, like a crypto version of pennies. From the Polygon blockchain, the point value is 18. Save the step answer to the context variable amount. To check that it's worked, we copy our object ID and immediately run it in the scenario, without publishing. As you see, in the Logs and Debugging menu, everything looks good. The amount equals 1, which is the sum of the transaction. Next, we decrypt the input. We'll need the Ethereum plugin, because it contains some useful utilities. The utility we need is called hex to string. It will allow us to convert data from hex to string format. But in our case, it will be JSON. To save the result, we add a new context variable: JSON type options. Open the object again and look at the field's name. It's called input. Save the result to the options context variable. Let's use the debugging menu to check that the scenario works correctly. Copy the object ID and look at the context variable's values in the logs. We see that we have JSON with all the parameter values we added. Don't forget to add comments to the scenario to make it more readable. Next is the JSON step. As a schema, we save what we have into our context variable. This context variable is the field that stores the JSON. Now we need to configure the mapping. We need to pull the cart ID field from the JSON. We don't need the other fields because we got the amount from value from the transaction parameter itself. Nevertheless, we see that the amount and user ID are correct. Save and check the scenario again via the debugging menu. Look at the context variables values in the logs. That's the ID of the cart for which the transaction was performed. Now we should add checks. For example, that this cart actually exists. Select a link, click on it, then select the ID field. If it's not empty, then that object exists. If there is no such object, the scenario stops. Ideally, we need to make an alert for the admin, because if there's no cart, then we have an incomprehensible transaction. By the second check, we've made sure that the transaction amount corresponds to the value of the cart. Select a link to the cart and select the sum, which should be equal to the transaction amount we saw in the first step. If not, then the scenario stops again. And if it's correct, we create an order. Don't forget to add comments. Let's create an object in the orders structure, and let's have a manual ID creation. For convenience, we'll use a set of 7 random digits. We'll start by configuring the mapping. Add an order status and copy all the necessary fields from the cart object by following the link, which is stored in the context. We copy the list of items, the amount, and the link to the user. The last step is to empty the shopping cart because it has been paid and an order has been created. We reset the order list and the cart's value. The scenario is ready. Let's publish and run it. Check that it works correctly by paying for an item in the cart. Wait for confirmation of the transaction in the Polygon blockchain. Usually that's quick and very cheap. Polygon is quite a ubiquitous network. You can manually run a scenario to receive transactions in the wallet to process them right now, rather than an hour later. In the logs, we see that the scenario worked correctly, and we have a paid order. You can remove the extra link that was left over from the template. Go to the Web Pages section, My Orders, and edit the Orders subpage. In this case, it's a component with HTML code that contains the template data from the object. Look again. Now, everything is correct. The order has been created, and the cart has been emptied.